I'm Dr. Elizabeth Michikowski, and I'm a chemist at San Jose State University. I'm also part of the American Chemical Society here in Silicon Valley. And this is my assistant for the day. Do you want to introduce yourself?
Yeah.
Go ahead.
My name's Lana, and Liz.
You're my niece, right?
Yeah.
That's why she calls me Aunt Liz. What else?
And I'm curious about science.
You are curious about science. You are. So the reason that we're doing this experiment, well, the reason that Lana is helping me do this experiment is because we had this self-inflating balloon. And we did this the other day, and after it inflated, Lana said, "Why is it inflating?" Remember that? So let's do it again so that people can see what I mean when I say self-inflating. Do you want to try it? It's kind of hard. You got to really smash it. Go ahead. Oh, can you get it? Oh, you got it. What's happening? What is it? What do you experience?
I hear it.
What's it sound like?
It sounds like sparkling water.
Sounds like sparkling water. That is such a good description of what it sounds like.
And it's going to get bigger and bigger.
Yeah, is it already starting to get bigger?
Yeah, see?
Interesting. Very cool.
It's getting a little bit cold.
It's getting a little bit cold? You're very observant. These are all good things that scientists do.
It feels hot in the middle.
Feels hard or hot?
Hot.
So what Lana has just done has been really good. She has thought about all the different things that she observes about her surroundings, and she observed about her experience. So let's talk about maybe what might be happening in here, and then we'll go on to investigate a little bit further. What is likely happening is a chemical reaction. Now, a chemical reaction that's happening in there is expanding the balloon by producing gas. And just in general, a chemical reaction is when two things join together to make something else. So let's start by having these two things. And I shouldn't say two things, two or more things. Sometimes it's one thing that breaks apart. But any time that a new substance is made, that is a chemical reaction. So Lana's going to start off with a substance that's red and white. I'm going to start off with a substance that is green and purple. So these are two different things. And you can imagine that each of these circles is an atom. So when we combine these two substances, let's combine them, shall we?
Okay, mix up and we get different ones.
Yeah, that's true.
We get different ones.
So what are yours now?
Mine are purple and white.
Yeah, and now mine are green and red. So the atoms we started off with are different from the atoms we ended up with. Very cool. So what might be happening inside of this balloon is we start off with two substances, mix them together, and get totally new substances, just like Lana and I just did. All right, so let's investigate. You want to give me those substances, and we'll see what substances are in here? Okay, now before we do this, we want to practice safety. And to do that, we need to wear goggles. Which goggles do you want to wear? Those ones? Put the goggles to protect our eyes. Can you see okay with those on? You look great. And we're going to put gloves on our hands to protect our hands. Now, nothing we're working with today is particularly hazardous, but we want to make sure that we are safe. You're blowing up a balloon just like the other balloon blew up. Go ahead and put that on your hand, silly. All right, so let's show the camera that we both have our gloves. We've got our gloves on, which means we can go forward.
Okay.
All right. So since our experiment is to figure out what is in here, I'm going to be the one opening it up and cutting it up. So we were given these two cups right here, and we're going to put the contents into these two cups. Now, what we think is that there will be two different substances that we'll put into two
and
of the
one's
cups.
going to be mine and one's going to be yours.
One is going to be similar to the one that you had. One is going to be similar to the one that I had. So let's open this up. Let's see what's inside. I'm just going to be careful when I pour this out. Pour it into this cup. All right, cool. So we have a powder that is a white powder, and we have a liquid in the bag. I think what happened, be careful, please. I think what happens when you
I know that thing's like blows up and then mixes into here and then blows up.
That's great. That's
Yeah,
exactly
okay.
right. So when she smashed the balloon, it smashed open this liquid container and it allowed it to react with this powder. So remember that in a chemical reaction, two things or more combine to make new products. So we hypothesize that the reason that the balloon expanded like that is because there was a new product forming, specifically a gas forming. And I think, just because of what I know about this, that this is probably a reaction that makes carbon dioxide. Have you heard of carbon dioxide?
No.
Carbon dioxide is a gas that our body produces and we breathe it out. So when you breathe in oxygen. When you breathe out carbon dioxide. Carbon dioxide is made in a lot of different reactions, including some of the reactions that occur in your body. Okay, so what we're going to do now is we are going to see if this hypothesis of ours is correct. If we can put these two things together and if they make a gas. Let's investigate. Make a little cut right here. Here we go. You can tell us what's happening. Whoa! Can you see the bubbles?
Wait, don't make it spill. Don't make it spill. It sounds the same.
It does. It does sound the same. And I thought it was so interesting that you said that it sounds like fizzy water, like sparkling water, because there's carbon dioxide in sparkling water too. So that was a really good way of explaining it, of describing it. Cool. So we just saw that the reaction that takes place inside of the balloon does indeed produce gas, and it is likely that that produces carbon dioxide.
Maybe.
Okay, so the next step in this experiment is to figure out what two things are reacting together to produce this gas. And basically answer the question, what are these two compounds that were combining within that balloon to produce carbon dioxide? We'll get there. You're just so curious, aren't you? You have so many questions. So what I'm going to do now is show you all the contents of the kit that you need to make this experiment. So the first thing that we need, which Lana just pointed out, are balloons. Now these balloons are going to act just like the balloon from the inflatable balloon, and we need 4 of them. 1, 2, 3, and 4. They're all pretty cool, aren't they?
These are
all right, you want to put those over there? We also need several of these rubber bands.
Can I pick some?
Sure. Why don't you go ahead and do that while I explain the other stuff we need.
Okay.
There, go ahead.
How much?
8, please.
Okay.
Here, I'll pour them out and then you choose the colors. In addition to the balloons and the rubber bands, we also have our chemicals. Or, well, let me go through the glassware first. So we need these 4, 1, 2, 3, 4 test tubes. And the order that these are going to go in is, let's see here, magnesium sulfate, followed by sodium chloride,
1, 2, 3, 4.
followed by sodium bicarbonate, followed by calcium carbonate. Okay. We have this scoop, which is a 5 milliliter scoop. We have a funnel that's going to help us to get this powder into the balloons. And we have this little measuring cup as well. So the compounds that we have are the same ones as are here. We also have citric acid, and we're going to make a citric acid solution.
I want to be 2 in each one.
Is there anything we need? I think that's everything, right? Yeah, you're right. There's going to be 2 on each one. So why don't we go ahead and set this up before we even make our citric acid solution. So we put them around the tubes like this. Can you try that? There you go. And then we'll keep those, we'll wait for the balloons for those, okay? So put those off to the side.
We're going
Okay.
to put those on these.
Yep, we're going to put the other ones on the balloons. So we have our rubber bands on all of our test tubes. Okay, now we need to make this solution of citric acid. So I'm going to take this funnel and put it right here, and then scoop 2 scoops of our citric acid. Do you know what citric acid is, Lana?
No.
Citric acid is a pretty easy to come by acid. It is readily available because it is found in citrus fruits. What is a citrus fruit?
That looks like sugar.
It does look like sugar, but it's not. Do you know what a citrus, can you give me an example of a citrus fruit? Do you know any?
No.
Lemon is a citrus fruit.
Orange.
Orange is a citrus fruit. What else?
I don't know.
Lime is a citrus fruit.
Stuff that is sour?
Yeah, that's really good. So the sour taste that you taste is actually the
I
acidic
know.
nature of it.
I know what to say.
What?
Really remember what it's called.
Well, you think about that. I'm going to make this, the rest of this solution. So we just put in the citric acid. Now we need to put in the water because the solution is something dissolved in something else. And in this case, it is citric acid dissolved in water. I'm
Okay.
putting in 250 milliliters of water that I measured out earlier. Here it goes. Still thinking of what it's called? Grapefruit, maybe? That's another.
Yeah.
That's what it was? I read your mind. Almost.
I know how to eat grapefruit and I ate it like 3 times.
Yeah, I bet you put sugar on your grapefruit, don't you? To
Yeah.
make it taste a little bit better. It's because of the citric acid in it.
All the time.
Okay, now let's mix up our citric acid solution. Okay, we're going to add 10 milliliters to each of these test tubes. Here we go.
Cold.
So 10 milliliters is about a third of this 1 ounce container. It looks like water because a lot of solutions are clear, but it is not water, it is citric acid. Now that we have 10 milliliters of citric acid in all of our test tubes, now we're going to set up the balloons. I'm going to put a balloon over this funnel like this. Yeah, you see how it's over the funnel? So that I can measure my substances into each of these balloons. When I do this, I want to make sure to keep all of the powder in the bulb of the balloon. Make sure that it's all kept in that bulb because I don't want it to spill out. And in fact, I'm going to start with magnesium sulfate, actually. For each of these balloons, I'm going to add 5 milliliters, or 1 scoop, a level scoop of my powder. Okay? So when I put the powder in, let me again say that all of that powder is going to be at the bulb of the balloon. Magnesium sulfate, by the way, this is Epsom salts. Have you ever heard of Epsom salt? If you ever want to have a nice relaxing bath, you can put some Epsom salts in your bath. When I put this over here, we're not going to put the contents of the balloon in the test tube yet. I'm going to keep them again in that bowl. So I'm going to put it over just like this. Stretch it over the test tube. Now once it's over, I'm going to take the rubber band and put it around that balloon. Again, trying not to put the contents of the balloon into the citric acid. There we go. Now just to make sure that nothing happens here, I'm going to put another rubber band over it to keep all of the powder away from the citric acid solution. So I'm going to do this for the rest of these components. Sodium chloride. Another name for sodium chloride is table salt. Do you ever put salt on your food?
No.
You don't ever put salt on your food? I bet your mom and your dad, when they make food, they put salt on the food to make it taste good.
Put oatmeal on.
They put salt in the oatmeal?
Yeah.
Yeah, that's a good idea. It makes it taste good, doesn't it? All right. Sodium chloride is in here. And I'm going to do the same thing. Again, making sure not to add the salt to my citric acid. So then I'm going to put the rubber band over the balloon to make sure that nothing happens. I've got 2 more to go. Sodium bicarbonate is found in baking soda.
So baking soda.
Baking soda. What do you use baking soda for? Do you know?
Mommy's bread.
Mommy's bread. Very good. So you put baking soda in bread. When you put that baking soda in bread, it helps with the reaction that makes the bread rise. Well, because remember what we want to do. We want to figure out what... Hold on a second. We want to figure out what the components of that balloon, that self-inflating balloon are. And so we're trying all of these different things. Now, the reason that we have citric acid in all of them is because citric acid is a weak acid, it is pretty inexpensive, and it is pretty harmless. So I can imagine that whoever made these self-inflating balloons used citric acid because, well, you can put it in a balloon and sell it for pretty cheap. The last one is calcium carbonate.
Calcium carbonate.
Try it again, calcium carbonate.
Calcium carbonate.
One more time, calcium carbonate.
Calcium
Carbonate. Carbonate.
Okay. Calcium carbonate.
Very good. Do you want to know an easier name for it?
Yeah.
Chalk. I made you say it the hard way, but I bet you play with chalk all the time, don't you?
Mhm.
So calcium carbonate is what is found in chalk.
Yeah.
All right, let's do it. Okay. Boom. Do you remember the question that we were asking?
What question?
We were asking why this balloon blows up. What reaction is occurring inside of the balloon to make it big? Do you remember that?
Yeah.
I know. So we have 4 different reactions that we're going to make. They each contain citric acid because we think that citric acid is a component inside of this balloon, and they contain some other substance. So what I'm going to do now is to release that substance into the citric acid to see if this makes a reaction that causes a gas product that then blows up the balloon. Exactly. Shall we do it?
Yeah.
Are you ready? Okay, but this one right here. Okay, are you ready? Okay, here we go. This is going to... Is anything happening?
A little light at the bottom.
Yeah, it looks like the powder just went to the bottom. Is the balloon blowing up? This is pretty uneventful, isn't it?
Let's just leave it there and maybe later.
Maybe. But the balloon didn't take that long, right? It went right away. So this is probably not the contents.
But it's staying up.
It's probably not magnesium sulfate, huh? All right, next one. So it's not the magnesium sulfate. And the magnesium sulfate, remember that was the Epsom salt. Sodium chloride, this is the table salt. I wonder if table salt is in there. Let's see here. When I pull it up like this, you can see that the rubber band that was on the balloon that holding it down is now just going to pop off. There it goes. Anything happening? Lana, nothing is happening. It must not be sodium chloride. I guess that table salt is not in our self-inflating balloon. Oh well. Let's try these two. Sodium bicarbonate. Remember the other word for sodium bicarbonate?
Chalk.
Not quite. The baking soda, right? Chalk. That one's chalk. Baking soda. Let's see here. Baking soda. What? Oh my goodness! Oh my goodness!
That one did work.
Yeah! Look at
So
that!
all the time we could do that. Now we know which one works.
We know that it's this one. It could be this one in there. Wow! How cool is that? So it might be the sodium bicarbonate, huh? That worked really well.
Let's see if another way.
Yeah, let's see if this other one works. The chalk. This one is calcium carbonate.
I wonder if it's going to work.
Are you excited? Let's see.
Nope,
Oh.
not going to work.
I don't know. Let's give it a second.
No. Only one worked.
Only one of them worked. Wait. It's kind of stuck. Chalk is kind of stuck in there. What do you think? What do you see in there? Is anything happening?
Yeah.
Can you describe what it is?
It looks like it's getting bigger now. Some of it.
Whoa!
He can't even make it up. Oh, is it going to turn into a chalk?
I don't know. Look, it's a bunch of bubbles though, isn't it?
Looks like a little bit of corn.
Yeah. So this one didn't quite work as well as the sodium
Look.
bicarbonate, but look, it is blowing up a little bit, isn't it? So it's about halfway, wouldn't you say?
Two of them a little bit worked.
Yeah. There's
Maybe
definitely.
we just have to shake those. Maybe we'll see what
try.
happens if we shake them.
That's a
See
good
what
idea.
happens if we shake them.
Anything?
Looks like they're just rounding up.
Yeah.
Let's see the other one.
Okay, let's see.
Nope, not gonna work.
Really only these two. So of these two, which one do you think is most likely in our self-inflating balloon? That one. Good for you. You can even see the bubbles. So these bubbles coming off are...
Now could I blow one up?
Give me a second. These bubbles coming up are carbon dioxide. And so there's carbon dioxide being made as a product from this reaction. That carbon dioxide is going into the balloon and blowing it up. All right, we did it. So luckily, cleanup is really easy. What we're going to do for cleanup is we're going to take a paper towel in here, and we will put the paper towel in our solution and throw the paper towel just in a regular garbage, and then you can clean out these cups and use them all again. With these, we're going to we can just toss these in the sink because it's just simply household waste.
Blow up a balloon now.
All right, now we're going to play with the rest of the balloons. Thank you all for watching.